36th Bitcoin Meetup. I'm very happy because today we are celebrating another all-time high for Bitcoin. So everybody is very rich right now. Okay. Okay, I'm starting.
And the flippening, Ethereum flippening didn't
No. We are waiting for the Ethereum flippening. Waiting again and again. Okay, let's begin. First, before the talks, we want to introduce you something very important for us at PHP Network. I'm going to read only some sentences from our statement that is going to be published in some minutes. This is our statement against the Segwit 2-pair proposed artwork. And this is the last meetup before that everything is going to happen. So, PHP Network is a research and development project committed to the long-term success of the Bitcoin protocol, intended as open, trustless, independent, permissionless. We regard the ongoing effort toward the scalability of this protocol as a very important issue that has to be faced in a safe and responsible way that doesn't compromise Bitcoin's decentralization and censorship-resistant nature. We believe that such principles are not compatible with the contentious artwork attempt called Segwit 2x. We think that Segwit 2x is actually an attempt to perform a political takeover of Bitcoin, as in no technical justification, but only political reasons, and as it's risky and unsafe, we cannot but completely oppose Segwit 2x. We invite the companies still upholding the New York Agreement to withdraw from it. There is still time to avoid dangerous and disruptive splits. We recommend to users to make sure they are in full control of their own private keys and to remove their bitcoins from compromised third-party services. Okay, now it's time for the talks. I'm not going to say a lot about our guest. I'm going to introduce the first one. This is Mark Erhardt, software engineer at BitGo. He stayed with us during the January meetup, but he's going to introduce a lot of new stuff about coin selection. What is the title? Coin selection and some remarks on Bitcoin 2017. Okay, it's your turn.
Hi, and welcome. I'm going to talk a little bit about coin selection and a few other ways on how to transact on the Bitcoin blockchain without losing tons of money. And then I'm also going to round up a little bit 2017 for Bitcoin because I think it's been a very interesting year. So first I would like to say thank you. Thanks for hosting me today. And this is the third time that I'm here actually in Milan. The first time was scaling Bitcoin last year. And since then I've taken a totally new trajectory into Bitcoin because I finished my master's degree in computer science, moved to California and started to working on a Bitcoin project full time. So Milan definitely helped get me there. And the other thing is I was here in January to talk about my master thesis. I wrote about coin selection, and this is the topic that I'm going to start talking about right now. So who here has done a Bitcoin transaction? Oh, that's a few of you. Good. Who of you have also looked at the Blockchain Explorer afterwards to see what happened on the blockchain? Okay, that's pretty good, I think. So, what is coin selection? Well, in your wallet you have bits of Bitcoin. We call them unspent transaction outputs. They were created by some transaction and they have not been spent yet, so they're unspent. And for coin selection, you basically try to fund that transaction in a way that minimizes your costs, maximizes your privacy, and keeps your unspent pool in good boundaries. So in my master thesis, I discovered that there's better strategies for this and worse strategies, and I talked a bit more about that in the January meeting. So I'm going to try to gloss over it a little bit. If you get lost, I recommend watching my Scaling Bitcoin talk or the January meetup again. So, but as an example, here we have two input sets. We're trying to spend 0.8 Bitcoin, and I would like to hear some ideas. Which of the input set is better, and perhaps an argument why that is the case. Anybody got an idea?
Set A,
Set A. Why set A?
because I pay just one fee.
Excellent. So set A has the advantage that you only have to pay for one input. Paying for inputs and paying for space in the blockchain is expensive, right? So in the right case, I would have to pay for 3 input sets. However, the right side also has some advantages. The left side will create a change output because you want to send back 0.1 Bitcoin to yourself. So this will link further transactions from your wallet to this transaction. So there's a small loss in privacy. On input side B, you have exactly 0.8 Bitcoins. So you will not create a change output, and there will only be a single output to the transaction, which will not link further transactions to you. However, you're using 3 inputs, which also creates some linkage. So I'm just trying to illustrate at this point, it is not always easy to say which input set is the best input set for coin selection. And especially privacy concerns are very different for some people. Corporations don't care about it at all. Some individuals care about it a lot. And then we do not know how the fees will develop in the next few minutes, in the next few weeks. We do not know how much demand there will be for block space. We do not know how quick the uptake of Segwit will be, or any of those things. So it's really hard to make assumptions about the future and how to pick input sets now for the optimal course in the future. So this is something that I researched a little bit, and the solution that I came up with in my master thesis I called the branch and bound algorithm. The branch and bound algorithm basically is a way to try out all possible combinations of the unspents in your wallet and do this efficiently, so I do not search spaces where I cannot find a valid set, and then create an input set that does not have a change output. A, I don't have to pay for the change output. B, I don't have to pay for spending the change output later. And C, it has slight privacy advantages. So this is what I presented in January. And since then, I was asked by one of the BHB members to run some more simulations, and I found that there was more efficient ways of implementing my algorithm. And in collaboration with some Bitcoin Core developers, I came up with a waste metric to make my selection even better. Because in the initial application of my branch and bound algorithm, I would just select the first input set that would have a smaller excess than what a change output would cost to create. So obviously, the first solution does not always have to be the best solution. So we combined this into a metric. The excess here is the amount that I selected exceeding the amount that I'm trying to spend to a recipient. So if I'm trying to send 1 Bitcoin to someone and I selected 1.001 Bitcoins, the waste would be 1 millibitcoin, right? Sorry, the excess would be 1 millibitcoin. And the other one is, how much do I think will I have to pay for an input at a later time? So if I expect that the fees will go up, only up from this point, I should try to spend as many inputs as quickly as possible. If I expect the fees to go down in the near future, I perhaps want to spend as little inputs as I can in order to have spend the inputs later when it's cheaper to do so. So the min fee rate is still a point of research. How do you predict the minimum fee rate that you will have later in the network, right? Anyway, this gives us a criteria to continue searching on the UTXO pool set after we found the first solution and find better solutions later. So one point that I skipped just on the last slide, there are now 3 implementations of my master thesis. There's one in Bitcoin.js, a JavaScript library, there's one in Bitcoin Core, and there's one at BitGo where I work now. So I'm pretty happy with that result. So, well, the thing is, my master thesis was based on some assumptions, as we do in science, right? So I assumed that in my whole test case, I always have the same fee rate. And it turns out that having various fee rates as they appear on the network lets the branch and bound algorithm succeed at finding an exactly matching set more often at high fees. Because then the amount that you have to pay for a change output is much higher at high fees than it is at lower fees. So it gives me a larger window to find solutions, and thus it succeeds at high fees more often. And it turns out that the branch and bound algorithm has to combine several inputs in order to find a matching set. So sometimes it selects more inputs at high fees than just selecting the largest input in the UTXO set. So, and it turns out in reality, it's a little more complicated. However, one thing that I'm definitely positive about is it will always help you keep your UTXO pool, your unspent pool, very small. So it will consolidate the bits, the bits in your wallet. I've also learned that if you are very observant and you watch the network for low fee times, if you manually consolidate your unspent, you can save even more money. So probably I'm gonna work towards having more consolidatory transactions at low fees and use branch and bound in the other cases. So talking about UTXO management, I've seen some scary stuff this year. So does anybody have an idea how many bits and pieces of Bitcoin there are in total?
How many takes off?
1.5 million.
5 million? Do I hear more? 52 million. Very good. Did you watch my presentation before? Okay, so so as you know, there's about 16.6 million Bitcoins today. This grew in the past year from 15.9 million to 16.6. However, at the same time, the number of unspents that exist in the Bitcoin network grew from 42 million to 52 million, so like almost 25%. And that means that the average size of the unspents that exist has reduced from 375 millibitcoins to 315 millibitcoins. So while the fees are going up and the value of Bitcoin is going up, so the US dollar value that we're paying for transactions is increasing, we are having smaller and smaller pieces of Bitcoin to push around. So this seems like a pretty bad direction things are developing. So just a few months ago, I saw a single wallet by a company that had 70,000 unspents in their wallet. So
Blockchain.
no, not blockchain. No, I can't tell you. So anyway, theirs is probably much bigger. Anybody want to hazard a guess how many blocks that would take to spend? Okay, it's 20 blocks worth of data to spend 70,000 unspent. So you have to basically buy 20 full blocks just to rescue your money. And I think for most companies, a good sized wallet should have maybe 500 to 600 unspents. For an individual with not much traffic, you might want to go for 20 to 100. And so 70,000 just seems to be that people are not really watching what's happening in their wallet. And so really funny, working at BitGo, we're a wallet service, I saw an email from a customer and they were inquiring about an input set that we had selected for a transaction of theirs, and it was not optimal because it could have been smaller. So this company also had quite a few unspents in their wallet, but they didn't know about that, but they did realize that we once selected a suboptimal input set. So I'm thinking that if you happen to have a Bitcoin company or are doing lots of transactions, you might want to look into your wallet a little bit, look at what your UTXO pool is doing. And right now, you have a great opportunity to consolidate your unspends, because in the past weeks, we've seen a lot of blocks that had space left. So this is an image from Segwit Party charts, and you can see this is the former 1 megabyte border. Looks like a line pretty much here. And all the little dots that are below this were blocks that had lots of space left for you to consolidate your unspends. Maybe even at 1 or 2 satoshis per byte. And I'm also happy about stuff like this. This block had 1.5 megabytes. So that's pretty awesome.
Wow.
So yeah, consolidate your UTXOs if you can. Don't consolidate them too few though, because you'll lose all privacy that way. Another way to save a lot of money on Bitcoin payments is, why would you send a single transaction for every single withdrawal that your customers are doing? Instead, just save up all the withdrawals of the last 30 seconds and send one transaction to pay out to all of them. This will make your input set much smaller. This will save you a lot of money, and you can consolidate at a later time when the fees are lower, right? So David Harding wrote an article on Bitcoin Tech Talk, just I think last month, and he came to the conclusion that you could save up to 80% of your transaction fees by batching payments. So again, if you're doing something like that, consider batching payments. And lastly, this is a project that I've been very passionate about. I was allowed to coordinate the Segwit implementation for BitGo. And BitGo is a wallet service that uses a... So we're a multi-signature wallet. We do not take custody of our customers' funds. Instead, we only countersign their transactions. So the customer holds 2 keys, we hold 1 key. They ask to create a transaction. We countersign it if it's in line with their policies set on the wallet, and then we broadcast it to the network. Before Segwit, we were using 295 bytes per input. So people that are very familiar with Bitcoin might know that regular standard inputs paid to a public key hash are 148 bytes. A 2 of 3 multi-signature input is slightly larger. However, with Segwit and the discount that is given to witness data, we arrive at a size of 139 V-bytes. V-bytes is the corresponding size, virtual size, that transactions have when they are counted in weight. So this is what you're going to pay fees for now that Segwit is active. And it compares directly to old-style transactions, because the virtual size of old-style transactions is exactly the size of them previously. So now, actually, a Segwit, a P2SH wrap paid to a witness script hash transaction input with 2 of 3 multi-signature, sorry, that was a mouthful, is smaller than a standard transaction input. So our customers that upgrade to the latest version of our software will now pay 53% less block space and save a lot of space for other people and pay a lot less transaction fees. So my boss told me to calculate the numbers for one of our bigger customers, and it turned out that they were doing several 10,000 transactions per month. And yeah, so they were not using Segwit yet. And so we calculated that they would be saving 16 Bitcoins, or at that time about $70,000 in transaction fees, if they switched only to Segwit. So as you can imagine,
Per day?
per month.
Wow.
$70,000 per month.
Wow.
But still, that's a few developer hours and stuff. So you can imagine that the response of them was something like, yes, we'll implement it next week. Okay, so now that's a little bit about, maybe rounding up coin selection. So coin selection is a pretty interesting problem because every user and every wallet has it. But in light of the other savings that I proposed, like using Segwit, batching payments, or What was the third? Anyway.
Coin selection.
Well, coin selection only has a few percent points of savings. There are some really low-hanging fruits with which you can save a lot of money at consolidation level. Yeah, so, now I would like to talk a little bit about Bitcoin's year 2017 so far. As you might remember, it started in February with this ICO craze, where people were getting donations for projects that the people that were giving the donations were thinking were investments, but didn't really enable the investors to get a payback. So it looks like people have gotten a little more cautious about giving money to those. We've seen some funny stuff just in the last days, like Tezos, the ICO that solves governance, having governance issues and kind of imploding. And we've seen a bunch of ICOs losing a lot of money because they were using the wrong wallets and the money got stolen. So please do a lot of research before investing into ICOs and stay away from them, unless you have done so and decided otherwise. And then, I mean, 2017 gave us 2 Bitcoin Core releases already. 014 had lots of performance upgrades. It's now much quicker to catch up to the chain tip again. We saw the UASF first on several altcoins, and then before it could be attempted on Bitcoin, it became unnecessary. We will never know if it was totally responsible or not, but it was definitely an interesting experiment. Then we saw a bunch of people get together, write up a decision of what they wanted to do, get a few more people to sign it also, and then announce that to the public as the roadmap for Bitcoin in the next 3 months. So I was asked by a person a little while ago, how is this any different than what Segwit is, what Bitcoin Core is doing with Segwit? Well, I think there is a significant difference, and the difference is Segwit has been developed in the public. It has been around for 2 years, and there was lots of discourse on conferences, on IRC channels, on mailing lists, and so on. At every point, all the information was public about it. And then in the end, the miners finally were the last ones to give in and to activate it after 98% of the nodes had upgraded already and were ready for Segwit, after a lot of companies had said that they were in support of Segwit. And I mean, looking at numbers like blocks with 1.5 megabytes, I don't think that this was a mistake. So Segwit 2x is different in that it was a small group that decided what should happen and basically pushed that out as a done deal. And this is not, in my opinion, not the way that Bitcoin protocol development should go. So Segwit activation, I think I've covered pretty well already. We had another very interesting experiment after years of block size debate. Is there a question? No, okay. After years of block size debate, the big blockers decided to put some effort where their ideas are and to fork off. After trying first to claim the Bitcoin brand, I'm happy that they implemented strong replay protection, and they're also working now on a unique address format, but it's not quite there yet. And they adopted a new name, which I think is the way to go for a project that splits off from Bitcoin and tries to do their own thing. Again, this is slightly in contrast with what 2x is doing. And then we very recently had the 015 release of Bitcoin Core, which gave us multi-wallet support and laid the last stones to ready for Segwit on Bitcoin Core. I forgot what else I wanted to say, sorry. But it's an awesome release. It's much, oh yeah, sorry. The UTXO database has been revamped and it will be much more efficient now and will have less spikes. So it should be easier to run it without hampering other services on the same computer. So this is kind of where we are in the year, and I think a lot has happened already. And still there's a lot of interesting stuff that's going to happen soon. So a project that I'm personally very involved in, I have been a moderator on Bitcoin Stack Exchange for a few years. If you don't know about Bitcoin Stack Exchange is that site that comes up when you type questions about Google and about Bitcoin into Google. And it's kind of like Stack Overflow, but it's all Bitcoin questions and a few altcoin questions. So we have 18,000 questions now, 22,000 answers. The community has been growing lately, and we're graduating to a full site. We are having elections right now for moderators. So if you have not discovered Bitcoin Stack Exchange yet, I'd love for you to go there and learn about Bitcoin. Also very exciting is Batch 32. This is a proposal by Peter Villiers and a few colleagues. They're going to introduce native SegWit addresses. If you had ever had to dictate a Bitcoin address to somebody, these new addresses, small caps and capital letters are the same, so at least that is out of the way. Also, they can discover up to 8 errors in the address and recover from 4 errors. So if you mistype something, pretty good chances that you actually still arrive at the same address. Then very close is also Bitcoin 2x. It's been pretty exciting watching the 3 future markets right now all kind of get to the same conclusion that it's worth about 1/6 of the actual Bitcoin token. I'm not saying it's a done deal. I think we should stay aware of what's happening. And there is a few really big companies pushing for this. They do have 84% of the miner support right now. The miners have announced that they have a war chest of $100 million set aside for mining at a loss and pushing through their wishes. So if you're really passionate about Bitcoin, this would be a great time to start running a full node and definitely to get your money into your own, your private keys into your own control. And then, well, I guess around the activation we will have quite the mess with brand confusion and replays and so on and so forth. So you might want to, if you don't know what you're doing, you might want to just abstain from transacting on the network for a little bit. As a multi-signature wallet employee, I'm also excited about Schnorr signatures, because signature aggregation will allow us to collapse all the signatures on a transaction into a single signature. And in a transaction input, about half the weight is just the signatures. So asymptotically, if you have lots of inputs, you can save almost 50% on the inputs by having signature aggregation. Even cooler is key aggregation, though, because you'll be able to use multiple keys to generate a new key from that, and then multi-signatures will look like single key transactions on the network. Multi-signature will become indistinguishable from from single signature. Schnorr signatures, I've seen the math. I was at Core DevTech in September. There's a few core developers currently working on an implementation for Bitcoin Core. I think that it's going to be a few more months at least, but it's very close. And the math is done. They do have a strong proof that it's correct. Very exciting. You might have also heard about masks. This is a little more abstract. You can encode multiple outcomes for an output into a tree and then only resolve one of the branches. This is called Merkleized abstract syntax trees. This is something that will save us a lot of money for more complex transactions such as Lightning Network, commitment transactions, and stuff like that. So maybe early next year. Maybe mid next year, but exciting stuff happening. Lightning Network. This has been talked about a lot, but a lot of people have concerns about scalability, and when I'm honest, I do too, because we have not proven that it scales easily. But a lot of people also don't understand, even if only the 10 the biggest transactors on the network adopt the Lightning Network, and start transacting with the other 9, creating channels between just those 10 people could lift a ton of transactions from the Bitcoin blockchain to Lightning Network. So I think it's pretty clear that at 10 participants, there would not be a scalability problem. And then we would just fail gracefully to scale, and we'd add a few people, and they would be a little more picky in the beginning who to add to the Lightning Network. And at some point, we'll have a fully fledged payment network that does instant transactions and is capable of transferring low amounts, which Bitcoin definitely is not made for. So, and far future, Mimblewimble is just super exciting crypto stuff, kind of like crypto dark magic, I think, because it's basically homomorphic mathematical operations on ECDSA points. You can do scriptless script, you can do lightning transactions and all sorts of stuff, but I don't understand half of it. Yeah. Well, I did meet Andrew Poyas this year already and talked a bit about it. I kind of get some ideas of the concepts. Okay, so I'm rounding up. I want to drive home 2 points, and that is, if you look at other open source projects, I think that Bitcoin is evolving fairly quickly. If you look back 2 years, what was happening on the network, how people were talking about Bitcoin, how the public perception was, what you could do with Bitcoin. It is going pretty fast. The problem is that a lot of people are standing extremely close and are losing the bigger picture out of sight, and they're getting impatient. And really, Bitcoin is going very fast, especially considering how safely it is being developed. If you look at other cryptocurrencies, like this one major cryptocurrency that just did a hard fork last week, with the code changes being merged 2 days before the hard fork, and the hard fork being announced 1 week in advance of the hard fork, you will realize that Bitcoin is actually much more decentralized than other. Oh, I'm talking about Ethereum, of course. So Bitcoin is a lot more decentralized and is being developed very safely, and it is being developed sound, and it's pretty quick for that. And I think that a lot of people are also getting a little hasty with block space. So yes, we currently have a limit, and yes, at sometimes it's really annoying that you're waiting for a transaction for a few days, or right after you send your transaction, the fees exploded and it's stuck because you send it at a lower fee. However, if you think about it, how many payments everyone does every day, there can never be enough block space to do all that on a Bitcoin blockchain. And it is important that Bitcoin has a limit against which it can grow its software quality and develop like funny ideas like Lightning Network, like Mimblewimble or sidechains or whatever. And this limit is going to enable us to do those software changes, to have the industry adopt those software changes, and not take the easy way out and just pushing up the block size limit every time somebody asks for it. So when some proponents of 2x say that they would like this to be a precedent for block size increases and that there will be many, many more block size increases, this seems like a wrong idea to me, because then I won't be able to run Bitcoin at home, and that's what makes it censorship resistant, and that's what makes Bitcoin interesting. Thank you.
You can answer from
Yes.
there. More professional. Thank you very much. It was a wonderful speech. So before the next guest, some questions from the audience. Raise your hands.
Oh, come on.
Shy.
It was interesting about doing consolidation during the low fee period. Is there any advice about doing that in a way that it's leaking less privacy than possible? I mean, because in a way you are like linking all your inputs when you do consolidation.
I think that the two are unfortunately very strongly opposed. I mean, you're trying to collect as many unspents as possible and consolidating them into a single output. So really, you're creating a ton of linkage. Optimally, you would do it over a long period of time and always spend a little more unspents to have a small number of unspents in your wallet at all times. That would be pretty good. Or you could perhaps consider mixing them a little bit. I think we'll hear more from Adam in a minute.
Okay, thanks. Just maybe I understand wrong. When you talk about the UTXO database, actually it's a little bit bigger in the 0.15.
Yes, the UTXO database did get bigger. This is because the UTXOs are now stored per UTXO and not per address. However, this increase in size makes it a lot more efficient in the resolution of finding UTXOs and deleting the ones that were spent. So it becomes more efficient at the cost of slightly bigger RAM size.
I just understood.
Oh, sorry, maybe I did not.
And also prevent the near-out service attack that we have seen in the Paris conference.
I don't know what you're talking about, sorry.
There is an attack that was presented in the Paris conference.
Oh yeah. Sorry. I kind of was close to Peter when this got announced, and he was like, "Yeah, we fixed that 2 months before he even thought of it." So it just wasn't merged yet and not published yet, but we fixed it like 2 months before he thought of it. So I don't know. I think there is much ado about nothing there.
Adding to Ricardo's question before, would it be reasonable to suggest to use maybe Tor to not leak at least the IP when you transact unifying UTXO, or that's just not even?
Well, there's a little bit of a game there, but really you only submit the transaction to one of your peers often, maybe to a few over time. So somebody would have to be side-billing you in order to really trace where a transaction came from. And there's actually another very interesting proposal right now. It's called Dandelion. I don't know if you've heard about it. It basically says that you would be pushing forward the transaction only to a single other recipient in your peer network for a while, and then at some point it gets broadcast to the network. So it's much, much harder to track where a transaction originally came from. I think that's going to come pretty soon, like a few months.
Other questions? No questions. That's some percent. Well, you were very clear.
Thank you so much.
Sure. So you can still ask questions to Mark later.
I helped write Bitcoin Stack Exchange, so you can also ask me about other stuff.
So yeah, so you can also ask about Bitcoin Stack Exchange. You can also go on Bitcoin Stack Exchange to ask questions to Mark later, and maybe you can also stalk him during the post-video. What? Oh yeah. So since now we have some problem of block space in our meetups, as you notice, we started to close the list. Actually, this time with a bigger room, we had more space, but we started selecting, asking for registration with closed number. So we imposed the max size limit as Satoshi in 2009. And as for this reason, somebody wasn't able to participate to Tolbase meetup 1 month ago. So me and I had the idea to create this one block width interview, and now there is coming soon, I guess next week, one block with Mark Erhardt, of course, and one block with Adam Gibson. So if you have, I encourage you to look at that as well. There will be other questions that Mark already answered to. Okay, so if you wanted to lose Adam,
Do for yourself.
no, that's your job.
Okay, sorry. I would just take 1 minute more before the presentation, because I totally forgot before to say the next Bitcoin Milan meetup will be at the end of November, and it will be very, very interesting. I don't know if I can say something about. Well, Probably there will be a battle between Bitcoin against Ethereum, and that's quite interesting. But there is going to be a surprise. Maybe we can have the cryptographically proof of the fake Satoshi. I won't say more about. You can figure out what is that, or maybe you just come at the end of November. So in the meantime, I'm going to present Alan Gibson. I'm very happy to have you here because you were in Milan during May, but you haven't a chance to present anything. Adam worked a lot on privacy and fungibility of Bitcoin, Bitcoin Swap, CoinJoin, and the title of the presentation on chain contracts. Oh, you changed it?
Yeah, I scammed
Oh
you.
my god, you scammed the co-creator of ScamCoinBot. Amazing. Okay, well, that's on chain contracts for privacy gains. Okay.
Thank you. Okay. Hello. So thank you very much for inviting me. First of all, that's very kind. It's great to get a chance to talk to people in the Bitcoin world. So yeah, I'm kind of going to talk about two. Sorry, can you hear me? Okay. Yeah. I'm going to talk about kind of two different but connected topics tonight. Actually, the connection between them is really segue, so it's very linked in to what Mark was saying, what we've been talking about. So first of all, I'm going to talk a bit about CoinJoin specifically. I don't know if everyone here knows what it is. I will give a brief explanation, and I also want to kind of give you some insight, some feeling for what the issues around it. So I'm not going to give you like a tutorial, here's how to do a CoinJoin or anything like that. It's more about the ideas, what it means, because I think that's the interesting thing. And then from there, we're going to look at a kind of slightly new idea that sort of mixes in SegWit and uses CoinJoin as well. Okay, so first of all, about me. I just put a few details here. My background, BB before Bitcoin. As you can see, I did. How do you do?
You have to. Oh, you have to point later.
Sorry, I'm a bit used to this.
Maybe this. The center one.
The center one. Yeah, so as you can see, I did various jobs before, but in terms of technology, I worked on something called TLS Notary, something that Thomas Bertani would know, but I don't think he's here today.
In London probably, but
yeah, it's a kind of a cryptographic protocol. I won't go into details. Join Market, though. Join Market is a project specifically for CoinJoin. And it's, as far as I know, the only actively in use CoinJoin project today. Although there have been other ones in the past. And yeah, my general interest is in fungibility tech because I think it's very interesting and it's also very, very important. So let's move on. That's just some things I've written. You can read that later. So CoinJoin itself, what is CoinJoin? I want to make this remark before I say what CoinJoin is, which is it's important to realize that Bitcoins don't have like little serial numbers, okay? So when I say Satoshis are not watermarked, that's what I mean. And I think most people who are sort of casually interested in Bitcoin today have the understanding that Bitcoin is perfectly traceable, and this understanding is completely false. 3 years ago, everyone who came to Bitcoin assumed that Bitcoin was perfectly anonymous, and this understanding is totally false. So the problem here is we have some nuance, and it's not obvious and it's not simple. So unfortunately, to really understand it, you have to think about it in detail. So so in a Bitcoin transaction, of course, as we were just investigating, transactions have inputs and outputs. They usually have more than one of each. Sometimes they only have one, but there can be many inputs and many outputs. If there are many inputs, we usually assume that it's only one person creating that transaction and he is selecting coins according to some algorithm as per the previous talk. But it is possible for multiple people to contribute different UTXOs or inputs to a transaction, combine them together safely without trusting each other. That's a critical point. They don't have to trust each other to do this. So I and Giacomo can make a transaction where he spends 1 Bitcoin, I spend 1 Bitcoin, and the outputs go perhaps to Mia and to Mark. Yeah? So we can have multiple participants, but critically we can have more than one person providing the inputs to a transaction safely. That's the core idea of CoinJoin. And CoinJoin is not an extra to the Bitcoin protocol. There are many clever fungibility proposals which involve adding extra features. This exists in Bitcoin from the beginning. So that's CoinJoin, and it's based on the fact that individual Bitcoins aren't watermarked. So another way to think of it is the mapping between the inputs and the outputs is many to many. So if there are 2 inputs and 2 outputs, you don't know if the first input is going to the first output, or is the first input going to the second output? You don't know, okay? And that's absolutely fundamental. All right, so a few minor remarks. Nakamoto, I've written that because Satoshi Nakamoto's white paper has a sentence in it which says that if more than one input is provided to a transaction, it implies that only one person owns those multiple inputs. And as we've just said, that assumption is false. So it's a very strange thing. It's one of the very few things, maybe the only thing in the Bitcoin white paper that is false. You can go and look at that. I've mentioned Maplejohn. Sarah Maplejohn was the first academic to do some detailed investigation of blockchain analysis. Like how can we actually de-anonymize or find linkages between Bitcoin addresses and ownership? And the first heuristic she wrote in her paper was, in fact, what Satoshi had written in the white paper, which is this assumption that if there is more than one input in a transaction, it is co-owned by one person. Yeah. So that's the assumption that blockchain analysis is based on, and we can invalidate that assumption with CoinJoin. Of course, it is not the only assumption made in blockchain analysis. It's a very big field nowadays. There are big companies with a lot of funding doing it, and they have many vectors of attack. This is just this heuristic, this assumption that all inputs are from one person is just the main one. It's kind of the backbone of blockchain analysis, and it's what gives rise to things like what are called clusters. If you probably haven't, but there is a website called walletexplorer.com, and it shows you if you choose an address, you can see, oh, this address is linked to all these other addresses, so they're probably in the same wallet, and it's via things like change addresses and fundamentally this assumption. Okay, so that's the brief ideas about CoinJoin. I want to, before I delve into more complicated things, think about how we can think about this issue of inputs and outputs. So here's a Bitcoin transaction. It's obviously unusual, it's a bit unrealistic with exact amounts, but okay. So it has 1 and 3, and it has 1 and 3. If you were to look at this on the blockchain, what would you assume is the meaning of this transaction? And by meaning, I mean, well, what is actually going on? We assume a Bitcoin transaction is a payment, correct? Yeah? So if this is a payment, what's the pattern here? I'll give you one example. Is it the case that, let's say it's Alice and Bob, okay? Suppose Alice, is she going to provide the 2 inputs, 1 and 3, and pay Bob 3 Bitcoins? That's a possible interpretation, correct? And then what's the 1 Bitcoin? What's that?
The change.
The change, right? Okay. So that's one interpretation. Can anyone see a different interpretation? A different possible interpretation, I mean.
Without CoinJoin.
Well, let's say CoinJoin. What do you mean? So this is, okay, Giacomo suggests CoinJoin. This is another possibility. It's a weird CoinJoin.
Yeah.
A little bit weird. Why is it weird? Because if Alice is providing 1 and Bob is providing 3, fine. Then perhaps Alice gets 1 and Bob gets 3. Logical. They don't want to lose money, maybe. But it's a bit of a weird CoinJoin, right? And the reason I say that is because it's obvious which input provides which output, yeah? What do we do? Oh, is it obvious though? Are there any other interpretations? So we said a simple payment, a CoinJoin, anything else? What if I told you there are at least 8 different interpretations of this transaction? What if I told you that? Would you believe me? Okay, so first of all, the first simple one, Alice pays Bob one coin using 4 coins, and Alice gets 3 change. Yeah, obvious. CoinJoin in quotes. It's a weird CoinJoin, but Alice could pay Alice. Bob could pay Bob. Sure. What about if Alice pays Bob 2 coins? What do you think of that? Most people don't think of that one because it's a bit weird, right? If Alice puts in 3 and gets out 1, and Bob puts in 1 and gets out 3, then Alice has paid Bob 2 coins. Okay? Is it likely? No, it's not likely. Alice could pay Bob 4 coins, but she just happens to pay him in 2 separate outputs. Why did she do that? Who knows? Maybe it's like a fake coin join, the whole thing is Alice. Yeah? Actually, that one seems ridiculous, and maybe it is, but there have been proposals to do fake coin joins, where you don't actually coin join, but you just do it yourself. Interesting. Alice could be paying, there could be more than 2 people involved, right? Because we've got 4 bits here, yeah? So there could be more than 2 people. There could be 3 or 4. Alice could pay Bob, well, I mean, you can read, right? Alice pays Bob 3 coins, and somebody else, Carol, 1 coin. Or Alice pays Bob 3, Bob pays 1, Carol receives 3, Dave receives 1. Okay? And I'm not even sure if I made a full list here. All of these are possible from such a simple transaction. Right? So the question is, what I'm trying to illustrate here is that many-to-many mapping makes interpretation actually much less obvious than it might seem. Yeah? If this one Bitcoin had a serial number and you could see the same serial number here, there's nothing to talk about, right? Yeah? So it's the fact that we don't have watermarks that makes all this possible. All right, so if you look at that list of possible interpretations, some of them are a bit silly, some of them seem just almost impossible. But to coin a phrase, implausible deniability. It's not plausible that happened, but it might have done. It's possible. Okay, and that's important. And I have a picture here of, this is supposed to be mirrors, maybe you can't see it. Then we have a phrase in English, hall of mirrors. I don't know if you know it, where you have lots of mirrors in the room and you get very confused because you're looking in this mirror, it's reflecting that one. So it's like, if you think about it, the problem here is that it gets very weird for a blockchain analyst, because he says, well, okay, I don't think it's that, because if Alice is paying, in our example where Alice paid Bob 2 coins, that's weird. I don't think it's that, so I'm going to reject that from my analysis. That possibility is not included. Then the person who wants privacy is motivated to use exactly the particular transaction pattern which the blockchain analyst considers very unlikely. So then everyone starts using the unlikely version, and then the blockchain, okay, well that's the normal pattern, so I'm going to use that pattern. So you see there's a kind of a feedback loop there, or a kind of a recursion. So what I'm trying to say there is that don't just keep the analysis so simple as, we'll only look at what's the most plausible transaction pattern. Now, just briefly, I'm showing you here a more, at least for now, a more normal coin join transaction pattern, which is where we specifically create outputs that are of equal size. Okay? And the reason we do that in coin join today is because it is very fundamental that there is no possible way to distinguish between these outputs. They were created in the same transaction, so not at different times. They have the same amounts. There is no serial number, no watermark. So even if it's obvious that that 5 created that 3 change, yeah, because 5 plus 2 is 3, and even if it's obvious that that 1 is the change, maybe it's not obvious, but let's say it's obvious that those 2 inputs were combined to create that change plus that 2, yeah? Even if you assume that that is obvious, still it's the case that you have created a very fundamental fungibility in equal sized outputs in a coin join. And that's the mechanism that join market uses, except the difference is this is very small, it only has 2 counterparties. Okay? Join market will generally see anywhere between 3 equal sized outputs up to maybe 7 or 8, although occasionally it's even higher. So that's how coin join works, and that's how it's used today. And I mentioned all this other stuff about implausible though, because I want you to see that don't assume it's not as simple as you think. And it isn't the case that you can just say Bitcoin is perfectly traceable. That's just wrong, basically. It's much more complicated. Okay, so that was some things about coin joins. Just some final points. The reason I want to mention this is I want to show you just a little bit more about how we use coin join in join market. What we focus on is something called a tumbler algorithm. And it's based on the idea of having a network of coin joins. So one coin join on its own has some very severe limitations for creating privacy. But if you combine them into a network, so you do multiple of them in a row, you can address things like amount correlation. I want to mention that here. It's particularly useful for amount decorrelation. Yeah? So if you put some coins into this tumbler algorithm, after some series of coin joins, the amounts coming out may not be obviously tied to the amount going in. And that requires thinking. Also, some other things. Okay, I mentioned Greg Maxwell's concept of the closed network. I think that was kind of because he mentioned that originally, that was kind of the inspiration for this idea, I suppose. Chris Belger, who's the guy who invented the concept of joint market, which I'm not talking about joint market in detail, sorry, but he invented the concept, came up with this idea of creating sequences of transactions. We're typically looking at about 10 to 15 transactions over a long period. Could be typically 1 day to 2 days. And you can get a decent amount, I think I said that here, you can get a decent amount of delinking effect from this kind of mechanism. But it's not simple, and that's why I mentioned specifically here practicality. Okay, you have very meaningful practicality limitations. First of all, the network issues, because you have to sort of, if not, you don't necessarily have to be online all the time on the network, but you have to keep coming back to the network. You have to keep trying to find counterparties, and you have an issue with your wallet being hot during that period to some extent. You have to actually be online with the potential to sign transactions and the security implications of that. And you also have problems of civil attacks, which you can have in any kind of interactive algorithm like this. So there's a lot of practicality issues around doing it. Okay, so that sets the stage, I hope, for what we're going to talk about next. So briefly, I wanted to mention segregated witness because I've been studying a lot of this stuff recently. For example, Lightning Network and CoinSwap I've been studying a lot, and what you appreciate as you study these things is just how crucially important segregated witness is at a technical level. So the non-technical explanation for segregated witness, just in case anyone here doesn't know what it is that you, instead of signing, no, not instead of, just sign the transaction itself. The meaning of the transaction here just means what are the inputs, what are the outputs, what are the amounts. Okay, you sign a bit more than that, but basically you sign the meaning of the transaction and you don't sign any authorizing data attached to that transaction. And the great benefit of that is it removes malleability. So malleability here is just meaning the fact that you can create a transaction, but you can change the identifier of a transaction without changing the transaction. And so with SegWit, that is no longer possible, let's say. But the thing is, this is a design bug fix, okay? It's a fix to the design of Bitcoin itself. And without either SegWit or something very similar to it, it was impossible to fix. And the reason it's important for these systems that I'm mentioning, Lightning, CoinSwap, and this thing I'm talking about today, is it allows dependency chains. You can make multiple transactions. You don't have to broadcast each one and wait for it to confirm on the network before you do anything else. So Lightning greatly makes use of that, for example. So Lightning covenants is another topic, and there are other things, and maybe what I'm talking about today. So that's why some people said that SegWit is technical debt. It's very bad. Bad code, technical debt. So what I want to do is I want to max out my technical credit card today, and I'm going to make maximum possible use of SegWit, okay? So there's my technical credit card. So here we go. So how about the idea of making not just one coin join transaction, but how could we maybe get some benefit from making lots of transactions without broadcasting them each individually? So in other words, perhaps I'm with Giacomo, we negotiate several transactions without broadcasting and without broadcasting. Now, in order to do that kind of thing, you need to have a shared control mechanism. Otherwise, it's not safe. So we're going to be using two addresses. You'll see that as we go on. So all or nothing. What we're going to do is make several transactions, not broadcast them, and then when they're all ready, we're going to be ready to broadcast all of them at the end. We may not broadcast them all at once because that's timing correlation. We don't like that. So we may use lock time. The good thing about making a whole set of transactions up front and not broadcasting them is it's not anymore required that there's a balance in the transaction. So Giacomo may put in 4 Bitcoins into one transaction and only get out 1 from that transaction, but in the whole set of transactions, he still gets his total amount of money. This is a possibility. So that's what I mean by unbalanced. And so we can get the coins out of this graph of transactions via each one. So bleed out to destination means the final destination. And we can include coin join itself in various ways. It's not so clear. So here's a very simplified diagram of what I'm talking about. Alice and Bob, okay, and they're going to fund a 2 of 2 address. Okay, this could, every time you see 2 of 2, it can be n of n, but let's say 2 of 2. Maybe they make up a whole set of transactions between each other involving various stuff, and different coins come out at different points to Alice and Bob. But we can have a refund transaction with a lock time, which means that we can sit down together or be on the network together and try to agree on a set of transactions. If we don't agree, no problem, even if we've already funded that, which we will in certain cases and others we won't. We can still get refunds. So that's the basic idea. The problem with this very simple model is it means that F is like the ancestor transaction. All these transactions kind of depend on it, which really limits what you could do with that. You're not going to get very interesting transaction graphs. You can still do something with it, but not much. Okay, and so the key idea, though, to make this safe will be to sign that one last. Yeah. So we're going to make a lot of transactions, decide if we like them, then each sign them so we're both safe, because the other guy can't do it on his own. And then only at the end are we going to sign the first transaction. Because if we sign the first transaction last, then there's no problem, because at that point we already know exactly what can happen with the rest of the transactions. Okay. If it's not clear yet, it doesn't matter, because I'll show two more examples. So we can do a lot better than this. Before I show the other examples, I want to mention anonymity set, because if we start using 2 of 2 addresses, it's a bit different, yeah? Because that means, okay, we can see that that's 2 of 2. Well, we can do n of n as well, but that's the same problem, maybe even worse, because the transactions will be bigger and maybe even more uncommon, n of n. So, also, yeah, so it uses signature space as well. Schnorr will fix those problems, as Mark said towards the end of his presentation. Schnorr will fix those problems because signatures can be aggregated. And we should be soon in a position where n of n signing is just the same as 1 of 1 signing, at least from the point of view of the blockchain. You just see one signature. So that's Schnorr. Master may also help, but I don't want to go into it. I'm not even sure, to be honest, what the impact is. So, and as I just mentioned earlier, we can get a timing correlation problem. If we make 20 transactions between each other and then broadcast them all at once, that's really an obvious flag or a fingerprint that something special is happening, yeah? Maybe. So that can be an issue. But we can address that with lock time, as I just said. By the way, somebody told me, somebody told me that Bitcoin Core puts lock times on all transactions by default, which means that actually, if we add lock times to these transactions, it's not really watermarking it, at least from the point of view of core. So that's good. Now, I want to show you how this would work with a bit more realistic and a bit more useful. And instead of just having everything come from that starting transaction, what if we add in UTXOs from other wallets during the process, right? So what I've written here, PTG, I mean the proposed transaction graph. So we could allow UTXOs from outside this graph to feed into it. But it introduces a risk because if I sign a transaction with Giacomo and I say, I'm going to use this UTXO in our 4th transaction, and then you sign it, you say, great, that looks good. You broadcast it, but whoops, I've double spent my UTXO in between times. So suddenly our transaction graph is broken, we've lost the trust, or we've lost the trustlessness, I should say. So it's really a promise to fund. It's not actually trustless at that point. So we can just add more refund transactions at specific points. Yeah? If I had my UTXO at one point, Giacomo can create a refund transaction in the transaction before that, so if I make that invalid, he can get his money out. So allows more realistic coin joining, and we can still negotiate everything up front. It doesn't change that. So this is a more realistic picture already. So actually, we don't need the refund at the start here. We have a series of transactions in our proposed transaction graph. In the 3rd transaction, Alice is providing a 0.5 BTC promise to fund, by which I mean a UTXO. And so all we need to do is just create a refund transaction before that transaction which sends all the money back to the original people. And so here, Alice puts in 0.9, Bob puts in 0.2. Bob can get 0.6 out in transaction 1, that's fine. As long as we sign all of this kind of atomically, yeah, it's fine. And you see at the end we create a coin join effect. And, well, yeah, so that's the basic idea. You see if the mathematics adds up, right? So here, Bob is getting 1.4 and Alice 0.9 in the refund because Bob provided 2 at the beginning, but he also withdrew 0.6 already. So he's already got that in the pocket. So he only needs to be refunded 1.4 at that point in the chain. Alice needs to be refunded her whole input. Alice puts in more there, so she gets more out at the end. So, yeah, is this construction very useful? Debatable. I would say probably not, but it can show you we can move forward from this, right? We can make this a lot more complicated. And I'll just give one example, just to emphasize this means there's no risk of fund loss using the refund. So here's one example of a more complicated, but it actually, although it looks complicated on screen, it's actually a very, very simple case. Just a lot of lines, that's all, right? But there's some color coding as well. So we fund. I want you to note that it's not necessary for both of them to be funding at the start. It could just be Alice providing the funding. It's still okay. It's still trustless. So every time you see a red, that means an input from one of the parties. So Alice provides UTXO into transaction 2, and Bob provides UTXO into transaction 3. And whenever you see a red, you will see before it, in the transaction before that, there's a back out or a refund there. Because Alice may not honor her promise to provide a valid UTXO there. Yeah. So there's a refund in advance. Now the blue, these ones are, they say 22AB1. That means 202 address for Alice and Bob, number 1. Yeah. 202 address, Alice and Bob, number 2. Actually, this is 22AB0, I didn't mark it. So what you see here is we have to create chains where there's common ownership or common control at each point in the chain. Because obviously it's no good if one of these transactions, has complete control by Alice, so then Bob has no, you get the idea. All right, so what does this really buy us? Well, I think it buys us, one thing it buys us is, if you're an attacker, by which I mean a blockchain analyst, you may have trouble identifying exactly the shape of this graph. Where does it start, where does it stop? Yeah? So that's already a good step forward. The other advantage, to me, the big one, is Alice and Bob can do all of this stuff right at the start. Yeah? Maybe just in 1 second. They can negotiate all of these transactions right at the start. That's the purpose of this structure. Instead of Alice, does a transaction and she waits for a block, and then she waits for 6 blocks, and then she does another transaction, and then, So it's a much more difficult if you have to interact over a long period, I think. And also there's the hot wallet issue, which I mentioned before. Anyway, so this kind of structure is getting close to what I mentioned at the start, join market, where we have a chain of coin join transactions between multiple parties over a long time. It's getting closer, except it doesn't yet have N of N. So it's a little bit more difficult with N of N. And if we don't have Schnorr, I'm not even sure if I can make that work, N of N, and be reasonable. Yeah, because with 10 of 10 signing, not very nice without Schnorr. So that's the biggest thing missing. But there's other differences, of course. Okay, so sort of high level, what are the advantages of this? I was thinking, maybe I should call this horizontal contracting instead of vertical contracting, because the reason I say that is, what's great about Lightning is you make a contract and then you just kind of make a new one on top of it and delete the old one, and then you make a new one on top of it and you delete the old one. There's more to Lightning than that, but that's, to me, the great thing about it. Whereas this is just, let's just make contracts where we just have lots of transactions on the chain. If we do lots of transactions on the chain, it uses a lot of space, but then that's just, this is a trade-off, right? We're looking for some kind of on-chain additional fungibility. So it's, I'm trying to say that this is maybe not the only way we can use it. Reduce interactivity, I mentioned. We reduce hot wallet exposure in some cases, maybe not all. And we can, because we're allowing transactions to have unbalanced amounts where I don't get all my money back at once, I think it makes blockchain analysis more difficult. there's definitely some things to investigate here. And just kind of overview, like, what I'm really noticing as I'm, seeing Mark's talk and talking to people here and looking at all these systems, is all these things, they just fit together really well. An example, the fact that Schnorr really, really helps with what I've just been saying. Segwit doesn't just help, it's absolutely necessary. This only exists because of Segwit. Schnorr is, enables script to scripts, which is another advance. And Mast probably works really well with Schnorr together because they're addressing two different halves of the scale and privacy issue in a transaction. That's addressing the script pub key side and the redeem script rather, and that's addressing the signature side. And so I'm not saying they're all connected, but they're all kind of working really well together as far as I can tell. And and lastly, coin join and possibly coin swap, which I didn't mention here, may take advantage of this kind of idea of on-chain contracting. So future developments. To make it useful, it would need to have more than 2 participants. You can do it with 2 participants. There have been coin join systems in the past using only 2. So it's of interest, but it's not really of as much interest as having multiple participants. If you have multiple, then it's not necessarily the case that each participant knows the transaction outputs of the other. So it's a bit complicated, but if you think about it, it makes sense. So there may be a way to use this with coin swaps. I haven't really thought about it. There may be a way to use it in other ways I just haven't thought of. Full stop. Right, so that's it. And lastly, thank you. There is a more detailed write-up there, and just some background reading and my contact details if you want to talk to me. Okay, thank you very much.
Thank you. So, questions?
I haven't heard anything about Tumbleweed. Is it because it is not in this set of technique, or is it something I missed inside the mix?
Are you asking? Is this working? Hello. Yeah. Are you asking? Is it related to using contracts? Transactions in contracts, or are you asking if Tumblebit is another?
No, because I never seen written Tumblebit, but probably it was inside something you have explained, or you hadn't covered.
It wasn't. I didn't put it on this talk, but it doesn't mean that I disavow Tumblebit. I wrote a very long blog post about Tumblebit explaining how I thought it was the best thing ever. So it's not a subject of this talk, but I do think it's a great technology. Yeah.
Okay, so I was right in not seeing it.
You were right in not seeing it.
Okay, perfect. Thank you.
Questions? So I have one. Why did you drop the paradoxical title of the content?
Yeah, sorry, I probably should have mentioned it. Although it was a joke, I think there's something to it, which is.
Wait, what was it?
What was the joke?
It was a reversible transaction, Bitcoin's best feature.
Yeah. Yeah. So it's not exactly the topic of the talk, but if you think about it, if we use refund transactions, we're kind of a little bit replicating a reversible transaction, right? So the general concept here is that people can get together, try to negotiate a transaction, a set of transactions, and not have to worry about trusting each other, because they can create a refund in their back pocket, so to speak. So I mean, it's an idea that if you're familiar with Bitcoin protocols, it's not strange to you. But maybe some people who don't know anything about this tech stuff, they don't realize you can create scenarios where there is a refund. I mean, everyone knows if you buy something with Bitcoin, you'll never get your money back, right? It's not really true. There is ways to create refunds. This is not the only way to create refunds. Of course, we can have multi-sig escrow as well, different kind of thing, but has its value. So yeah, reversible transaction.
I didn't understand how it should be different from should time lock contract script. That concept is really similar to this one that you explained.
Right. Can you hear me, by the way? Is this mic working?
Yeah.
Yeah, it is different. So with the hash time lock, it is different. With the hash time lock contract, what you're mainly doing is creating atomicity. You're creating, making different transactions atomic by using the pre-image of a hash, right? So you can use that for privacy advantage, because you can create. I can pay Giacomo in one transaction, and Giacomo can pay me in another, that are not. They have totally separate transaction histories, and we don't have to trust each other. But that's a different technology. So I just mentioned briefly at the end here, I'm not sure if there's a way to sort of somehow combine this kind of idea of preparing multiple transactions in advance with that kind of idea of creating atomic swap type transactions. I'm not sure if there's a way to, they're kind of different concepts. This one is a tree or chain of transactions which are connected, whereas atomic swap, or HTLC for that matter, is transactions which aren't connected. Yeah.
But you need to trust. In this kind of transaction, you need to trust.
This, what I'm presenting here, no. The idea is that we can sign everything in advance. So if I don't like the terms of our transactions, think of it as us sitting at a table, you know, and we make a set of transactions with each other. We sign, you know, the documents, and each transaction, each contract is connected to the previous contract. So if we sign the first one in the chain last, then there's no possibility of there being later transactions that we don't like going through onto the network. They can't, because we never signed them unless we agree to them. It's not so easy to understand. Yeah, sorry.
So currently I have the impression that analysis is winning over fungibility efforts. Yeah, you won't be able to log in.
Okay.
So what can we do to push the fungibility side of things? What's going to happen to improve that? And is it a lost battle, or is there some fight left?
Well, that's why I was emphasizing at the start. I think people tend to forget the intrinsic fungibility of Bitcoin. Now, I know full well that there are reasonable positions to take where, they'll always be able to use metadata, they'll use many levels of data to connect things, and I think it's true. But first of all, you know, the second layer transition, so the more we get Lightning, that is going to make a huge difference. And, you know, well, I just think, like I said at the start, that it's just wrong to think that the battle is totally lost or the battle can never be totally won within the Bitcoin system. So we can make, I don't know where the crypto is going to go. Yeah, I mean, if we had confidential transactions, then CoinJoin becomes massively more effective. If we had Schnorr and definitely confidential transactions, it might create more incentives for people to do transactions of this type, or of the CoinJoin type. It's hard to say for sure, but I think people tend to overestimate how powerfully successful the blockchain analysis companies have become, because it's in their interest for marketing purposes to tell us all how effective and powerful they are. But you know, there's a lot of crime that goes on where the Bitcoins are not traced. It does happen, and it's been happening for years, you know. So, although a lot of idiot criminals do get caught because they do really stupid things, but so I'm not sure. It's a good question.
So, some parts of the contracts you described as some similarities with or overlaps with Lightning contracts, a little bit. In your opinion, it's a difficult question if you didn't do a specific analysis about that. But do you think that some part of this could be put on top of the normal Lightning working, so to having the instant the channels with some pre-designed privacy add-ons, or this is something that should be completely on-chain and separated?
Well, actually, what you could perhaps do is have a CoinJoin transaction that creates a Lightning channel. So that would definitely tie in together. And then, of course, Lightning channels can pay out part of their balance. And this could, again, be an input into a CoinJoin tree that you already have. So taking your question here, but I think, yes, definitely.
This was a question wall, like question join. Last questions?
We are talking now tonight about custom-made transaction, very complicated and made custom and just for the purpose. They must not be in a pattern or in a template that everybody uses.
Yes.
But is there some tool available to prepare this transaction, or how a normal individual would use to prepare this kind of transaction?
Thanks for the
Sorry, and to integrate, so I think that part of the question is also how you have to do templates in order to do that, and if you do have templates, then it's probably easier for an
I think this is what really interests me about this, is because you can imagine this is a very interesting software problem, because you could start thinking, how can we make patterns of transactions that are not just static templates? Maybe we could make patterns that fit the behavior of your wallet for the last month. You know, that's one way to do it. Or you could decide, it's better to just be random. Let's make completely random patterns. Or you could try. You want to hide in the crowd, right? So maybe you hide in your own wallet's behavior, or you hide in typical wallet behavior. I don't know. It's a fascinating question. Yeah.
Yeah,
So good question.
there are no tools of this.
Oh, I don't. This doesn't exist, by the way. I just made this up last week. It's just general ideas at the moment, but I think it's really interesting. I appreciate that question in particular, because I was thinking the same. I had the same question.
Okay. Yeah. So I have another question. If somebody asked you, I really want to make a transaction right now, and I really I do own Bitcoin.
Yeah.
I do need privacy
Yeah.
for this operation because of business reasons. Would you suggest, many people here maybe they know that altcoins are not trustworthy in the long term, financially and technically, but maybe somebody would say, let's buy Monero for this, use Monero, and then check back to Bitcoin. Would you suggest that over trying something like this or not, and why?
Yeah, it's a really tough question. I think ideally, the question is, what's your threat model, right? Because I use CoinJoin all the time, even just ordinary retail payments. And the reason I use it is because I think it helps the general network's fungibility to use it. I don't really care that much that somebody knows that I bought some pair of trousers or something, But if you're a criminal, well, I'm not here to help you, first of all. But if you're really serious about privacy and you're considering like state actors, I don't think the join market's going to help you. I have my doubts about Monero, although I see the point, and it's a complicated discussion. But if you start combining, maybe you should seriously consider combining several measures if you have very serious privacy needs. But also it depends on your time frame, right? Because if you don't mind waiting half a year to get better privacy, you can do things more passively. It's actually more effective. Like running join market today, probably the best way to do it is just to run it passively. As long as you're okay with the security considerations, run it passively. You'll do a lot of coin joins over a period of months. And it's going to get very, very hard for someone to identify your UTXOs. Also use it in a kind of mixed pattern. Don't just act as a maker. You can act as a maker and a taker. If you don't know what that means, I don't blame you, but read about join market. Things like that. Or you can mix, hey, throw coins into Monero. If you can deal with the trust issues with that, do that for a while, then take it out, and then do something else, and then do something else. But it depends on your threat model.
Move your money.
What's that?
Move your money in general.
Yeah, but I prefer just staying on Bitcoin because it's. I don't like services like Shapeshift, for example. I don't like them at all for various reasons. And Monero, I am a little bit concerned about. They're too aggressive on the cryptography. It's they've made some quite serious mistakes over the last year. I think it's great that they're experimenting, but I would just be cautious about that aspect.
Yeah, I didn't mention Zcash because there are like 2 users using the Zcash private transaction, so unlimited set is not so.
So today to do the
Yeah, I'm listening. Yeah.
joint market transaction that works, not this one that came from last week, you have to pay for privacy in terms of other than the fee of the for miners, also the maker of the joint market.
Yep.
But tomorrow with Schnorr there will be probably positive incentives in making joint market, and I'm looking forward to that. There will be a future where you will pay less for a joint market transaction than for a normal one.
Yeah, I think it's a great point, and also, yes, sorry, I was thinking about something else. Yeah, Schnorr specifically, you're right, will create a positive incentive for doing coin joins, and I think we were mentioning it before, right? The weird situation is today, the problem with doing coin join is you have to interact with other participants, which is annoying. You don't really want to identify yourself, so you have to do things on the network and use Tor and mess around sending messages backwards and forwards, and things can go wrong. So there's a lot of negative incentives to do coin join from that point of view today, and as you absolutely correctly point out, if you get extra advantage by aggregating signatures, it would be, is that right? I guess there is a positive incentive there, so an economic incentive which counteracts, yeah, so yes, I agree.
So a question to both. Do you have any, okay, then there. Do you have any news, and then we will set you free, I promise. Do you have any news about companies thinking about integrating joint market as default inside wallet? Maybe you, Adam, talking about that, or maybe you, Mark, your company?
My question is really connected to the last one. Indeed, I'd like to understand if you have talked to some consensus model in order to reach the consensus over this transaction between two participants without expect too many times
Right.
in order to make this kind of transaction and without weighted trust between these participants.
Yeah, I think I understand what you're asking. You're asking like, if you start this kind of negotiation, then there's a problem where you get a Sybil attack where people try to block it, try to stop it completing. Yeah, I mean, I haven't, but the first point is that because it's very fast, it might be less of a problem, but I still think your question's a very good one, and maybe we should research ways to do that. Like, for example, CoinShuffle, it attempts to address this, but I would caution people it doesn't address it in the complete way that they think it does. But this is a very long technical discussion, but very good question. I don't have an answer.
So, thank you very much to Adam and Mark. Thank you.
I want to thank again Adam and Mark because the topics were very complicated and they have done an amazing job. And also I want to thank Timothy for the streaming, Gaia for the picture, and also the guys that are voluntarily helping us all the time. Thank you very much, I'm very grateful. So, see you next month, and thank you to the audience. Thank you. Bye.